Hello everybody, and this is chapter 10.4, Vectors in the Plane. So today you're going to be learning about two-dimensional vectors, initial point, terminal point, and equivalent, magnitude, vector addition, scalar multiplication, vector operations, unit vectors, and resolving the vector. So first we have a two-dimensional vector, which is just the components of A and B, like any other ordered pair. And so the vector has an initial point, which comes in down here, an initial point, and a terminal point. You can see that here with the origin and 7, 6. And then the equivalent is just if a vector have the same length, but in a different spot. So now on to magnitude. So if V is represented as x1, y1 to x2, y2, then the absolute value of V equals the square root of x squared minus x2 minus x1 squared plus y2 minus y1 squared. Very similar to other formulas that you've seen before. And if V equals the ordered pair A comma B, then add the absolute value of V equals the square root of A squared plus B squared. Now an example of finding the magnitude, you can go ahead and try this one yourself if you can. So you want to find the magnitude of V represented by the vector AB, where A is 2, -3, and B is 4, 2. So to do this, you're just going to plug it into that formula that we have up here. And so it's going to be the absolute value of the square root of 4 minus 2 squared plus 2 minus -3 squared. And that gets you to the square root of 2 squared plus 5 squared. And then that comes out to square root 29, and you can't go any farther with that for the purposes of this video. So the square root of 29 is your answer. So now we move on to vector addition and scalar multiplication. So if U is the ordered pair of U1 and U2, and V is V1 and V2, then K is going to be the real number, which represents the scalar. And then if you wanted to do U plus V, it's just going to be U1 plus V1, comma, U2 plus V2 to get you another ordered pair. And if you wanted to multiply one of the vectors, then K, which would be, whatever real number you have, so then you would just distribute it. So it's going to be K times U1, comma, K times U2 to get another ordered pair, which would be your answer. So for another example, if you have U equals 3, -2, and V equals 6 and 4, they want you to find 3U plus V. So in order to do that, you want to do the 3U first. So it's going to be, so you're going to take the 3 and multiply it by each point of U. So it's going to be 3 times 3 and 3 times -2, which comes out to be 9, -6. So now when you go over here and plug it in, it's just going to be that point that you just found plus the vector V. And so then you're going to have 9 plus 6, -6 plus 4. So then your final answer is 15, -2. Now we move on to unit vectors. So unit vectors is when the absolute value of the vector equals 1. And So like I said, the vector u is when if it's the absolute value of vector u and it equals 1, it's going to be the unit vector. And then u equals v over the absolute value of v equals 1 over the absolute value of v. So if v is not a zero vector, then the vector so if v is the unit vector in the direction of v, so then we're going to go on to the standard unit vectors, and that is when you have vector I and vector j, and so you if the vector is, you know, how we talked about before, a comma b, then you're going to have a comma 0 plus b plus 0 comma b, because you're using these, and then you're going to take out the a because you're plugging the other points in, so then you're going to have a to the I plus b to the I. So they're just showing you that this is the same as this. Now on to resolving the vector. So if v has a direction angle theta, the components of v can be computed using the formula v is equal to the absolute value of v times cosine of theta, the absolute value of v times sine of theta. And from that formula, it allows the unit vector in the direction of v, which is u equals v over the absolute value of v, which equals cosine of theta and sine of theta. So now we're going to go on to the examples of that. And at this point, I encourage you to pause the video and try to solve them on your own. So this one's asking you to find the components of vector v with the direction angle 135 and a magnitude 6. So we're going to use one of the formulas that we just had. So if v is equal to the a comma b, then you're going to have 6, which is the magnitude, times the cosine of 135, 6 times the sine of 135, and 135 is the direction angle. And then you're just going to solve it using your unit circle or however you want to find the cosine of 135, and then you're going to multiply by 6. And then you come out to have 3 square root 2, comma 3, or negative 3 square root 2, comma 3 square root 2. And then you just have a equals and b equals, because it's right there. And then we have another problem. Again, go ahead and pause this one if you want. Find the magnitude and direction of angle u equals 3, comma 4. So on this one, you're going to be going backwards from what we just did. So you have the absolute value of u equals square root of the 3 squared plus 4 squared. It's going to come out to equal square root of 25, which everybody knows equals 5. So then you have to find the direction angle. This is your magnitude. So you're going to do u 3 comma 4. So you're just going to plug it in like we did up here, just you're looking for the cosine x and the sine x. So it comes out to be 2 equals 5 cosine x, and then your answer, if you plug that in, is going to be 56.3. Now we're to our last concept, and that is, this is going to help you a lot with the next section. It is velocity has both magnitude and direction, which makes it a vector, which is something really important to remember. And that the magnitude of velocity is speed. So those are really going to help you in your next video. And thank you for watching. Hope you enjoyed and learned something. Thank you.